Hello, hi everyone. Welcome to this study brand. So today we are going to discuss about electric current, CBSE Grade 10 physics. Okay, so now in this topic we'll discuss about electric current definition, electrical appliances, conventional current and electric current. After that, electrical potential and potential difference. After that, Ohm's law. After that, resistance and resistivity differences. After that, resistors are connected in series combination and resistors are connected in parallel combination. We will discuss all those points, right? Yes. Now, electric current. Electric current. Electric current. So the rate of flow of charge is called electric current. The rate of flow of charge is called electric current. I equal to Q by T. Rate of flow of charge. I equal to Q by T. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second is called electric current. I equal to Q by T. So 1 ampere equal to 1 coulomb per 1 second. So SI unit of current is defined as, so 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. Okay, so I equal to Q by T. I equal to Q by T. I hope it is very clear, right? So SI unit of current is ampere, SI unit of charge is coulomb. Here, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So that is about electric current. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. And charge is quantized. So that is nothing but Q equal to Ne. So N is number of electrons and 1 electron. So 1.6 into 10 power minus 19 coulomb. In 1 electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? In 1 coulomb, 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons. And 1 electron, 1.6 into 10 power minus 19. So in 1 coulomb, 6.25 into 10 power 18 electrons are present. So very, very important this one. So make sure that you are remembering this point. Okay. So next one. Electrical appliances. We'll discuss electrical appliances. Electrical appliances. So cell, battery, resistor, rheostat, ammeter, voltmeter, wire joining and wire crossing. So we'll discuss now. First one is cell, positive terminal, negative terminal. Next one is battery. And third one is open switch. Fourth one is closed switch. And fifth one is resistor. Sixth one is rheostat. Next one, seventh one is ammeter. Eighth one is voltmeter. Ninth one is bulb. 10th one is wire joining. 11th one is wire crossing. So these are the electrical appliances. These are the electrical appliances. Once again, check here. So cell, battery, open switch, closed switch, resistor, rheostat, ammeter, voltmeter, bulb, wire joining, wire crossing. So resistor is a device. Resistor is a device used to oppose electric current. Resistor is a device which is used to oppose electric current in the circuit. Rheostat is a device which is used to regulate the current without changing the voltage source. Regulate the current without changing the voltage source. Okay, so that is about rheostat. So this is about electric current. Okay, next. Okay, so now we will discuss about now we will discuss about electric circuit, conventional current and electric current, conventional current and electric current. So we'll discuss now. Okay, so current is flowing from positive terminal to negative terminal. So flow of charges will move, positive charges will move from positive terminal to negative terminal. Electrons will move from negative terminal to positive terminal, negative terminal to positive terminal. Okay, so now you can observe here point number one. Point number one, conventional current, conventional current, conventional current, conventional current, and second one is electric current, electric current, conventional current and electric current. Conventional current, but the flow of positive charges. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. So conventional current is nothing but flow of positive charges. Positive charges are moving from positive terminal to negative terminal. That's why we are considering the conventional current. So electric current. So electrons are moving from negative to positive terminal. Okay. So flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Next, so I'll discuss about potential difference and electrical potential. Potential difference and electrical potential. Potential difference. Potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. So I'm taking this one. So there is a positive charge, this 2 points. So we are taking positive charge. We are doing some work to bring unit positive charge. We are doing some work to bring unit positive charge from point A to point B. We are doing some work to bring unit positive charge from point A to point B. That is called a potential difference. V equal to W by Q. V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. 1 volt is equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay. So here you can observe we are doing some work to bring unit positive charge from one point to another point. V equal to W by Q. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. Okay. So that's enough. That is about potential difference. Now electrical potential. Electrical potential. Electrical potential is nothing but work done to bring unit positive charge. Okay, so this is the infinity. So we are taking positive charge. This is the field. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field. From infinity to the required field. Okay, so we are doing some work to bring unit positive charge from infinity to the required field is called electrical potential. So V equal to W by Q, same. Okay, so we are taking like this electrical potential difference and electrical potential. So potential difference is nothing but work done to bring unit positive charge. We are taking unit positive charge from one point to another point. Okay, so V equal to W by Q. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Okay, so coming to the electrical potential, we are doing some work to bring unit positive charge infinity to the required field. So this is our required field. We are doing some work to bring unit positive charge from one point to another point. Okay, so from infinity to the required field is electrical potential. From one point to another point is potential difference. Okay, so is it clear? Next, now we will discuss about Ohm's law. So now be ready. Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So I am taking here cell 1, 2, 3, 4. 1, 2, 3, 4. Ammeter. Here I am taking the resistor. Switch. So potential difference is directly proportional to current flowing through it at a constant temperature. V is directly proportional to I, V equal to IR. V equal to IR. Okay. So the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. Okay. So materials required. What are the materials required? Materials required. Materials required. Materials required. Point number one. So 4 cells of 1.5 volts each. 4 cells of 1.5 volts each. Second one, nichromire is an alloy of nickel, chromium, manganese and iron metals. Nichromire is an alloy of nickel, chromium, manganese and iron metals. And third one, so ammeter and voltmeter, ammeter and fourth one voltmeter, and the next one, fifth one is switch, and sixth one is connecting wires. Okay. Now procedure is first connect one cell and note down the reading of ammeter and voltmeter. Next connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Okay, and mention in the tabular form given below. Serial number. So number of cells. Check once. And if you draw the VA graph, the graph is straight line. VA graph is straight line for ohmic conductors, and VA graph is not straight line for non-ohmic conductors, that is curve. The graph is curve for non-ohmic conductors. Okay. So now you can observe once again, Ohm's law I'll explain, listen carefully. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to V equal to IR. Materials required. 4 cells of 1.5 volts each, 1.5, 1.5, 1.5, 1.5 like that 4 cells. Nichromire is an alloy of nickel, chromium, manganese and iron metals. And ammeter, voltmeter, switch and connecting wires. Procedure, first you have to connect one cell and note down the reading of ammeter and voltmeter, and connect the two cells and note down the reading of ammeter and voltmeter, and connect the three. Repeat the process for 3 and 4 and mention in the tabular form below. So VI graph gives straight line because this is for ohmic conductors. VI graph is curve for non-ohmic conductors. Okay. So this is about Ohm's law. Next one, resistance and resistivity we will discuss. Resistance and resistivity. Resistance and resistivity. So the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. So resistors are connected in series combination. Resistors are connected in parallel combination. Now we will discuss. Okay. So right. So R is directly proportional to L. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. Okay. So R is the resistance. Rho is the resistivity. R is the resistance. Rho is the resistivity. Okay. Now we will discuss about differences between resistance and resistivity. Resistance and resistivity will discuss. So number one, R is R equal to rho into L by A. So first one, rho equal to RA by L. RA by L. So second one, so SI unit of resistance is ohm. Here SI unit of resistivity is ohm meter. And coming to third one, so resistance depends on temperature. Here resistivity also depends on temperature. And fourth one, resistance depends on metal of the conductor. Metal of the conductor. And here also resistivity depends on metal of the conductor. Metal of the conductor. Okay. So I hope it is very clear. So this is about resistance and resistivity differences. Resistance and resistivity differences. Now we will discuss about resistors are connected in series combination and resistors are connected in parallel combination. Okay, so next, resistors are connected in series combination and resistors are connected in parallel combination. We'll discuss now. Resistors are connected in series combination now. Resistors are connected in series combination. Check once here. Okay. So you can observe here resistors are connected in series combination. Okay. Resistors are connected in series combination. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR. So enter the circuit. Okay. So enter the circuit, current is same. So now Vs equal to V1 plus V2 plus V3. So IRs equal to IR1 plus IR2 plus IR3. So I am taking I common. I am taking common. So Rs equal to I if you take common R1 plus R2 plus R3. So I get cancel. Rs equal to R1 plus R2 plus R3. So if resistors are connected in series combination, the total resistance is Rs equal to R1 plus R2 plus R3. So here you can observe. So R1, R2, R3. R1, R2, R3, three resistors are connected in series combination. Across R1, V1. Across R2, V2. Across R3, V3. So voltmeters are connected. So IS equals, so throughout the circuit current is same. That's why Vs equal to V1 plus V2 plus V3. So potential difference of overall circuit is equal to potential difference of individual. 1, 2, 3. So that's why from Ohm's law V equal to IR. So V equal to IR. So IRS because current is same. That's why IRS equal to IR1 plus IR2 plus IR3. I we can take common. I get cancelled. The remaining values are, so IRS equal to I R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So this is about resistors are connected in series combination. Coming to resistors are connected in parallel combination. So resistors are connected in parallel combination. Resistors are connected in parallel combination. So from Ohm's law, V equal to IR, I equal to V by R. From Ohm's law, V equal to IR, I equal to V by R. So throughout the circuit, potential difference Vp equal to V1 equal to V2 equal to V3 equal to V. Okay. So current is dividing, potential difference is same. That's why Ip equal to I1 plus I2 plus I3. That is nothing but V by Rp equal to V by R1 plus V by R2 plus V by R3. So shall I take V common? V I am taking common. So 1 by Rp equal to 1 by R1, 1 by R1 plus 1 by R2 plus 1 by R3. So V will get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equal to 1 by R1 plus 1 by R plus 1 by R3. So if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. So Rp equal to R by n. Okay. So once again check here. So here you can observe R1, R2, R3 all are connected in parallel combination. Potential difference across R1, R2, R3 is same. That's why Vp equal to V1 equal to V2 equal to V3 equal to V. Current is passing from positive terminal to negative terminal. So here from Ohm's law, V equal to IR, I equal to V by R. V equal to IR, I equal to V by R. So current is dividing I1, I2, I3. So overall current passing in the circuit is Ip equal to I1 plus I2 plus I3. So here Ip equal to V by R, V by Rp, because potential difference is same. That's why I'm writing V only. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So V I am taking common 1 by Rp equal to V I am taking common 1 by R1 plus 1 by R2 plus 1 by R3. V will get cancelled. The remaining value is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. Okay. So this is about resistors are connected in parallel combination. I hope it is very clear. So if you have any doubts, you can ask. Right? Yes. So next one. Next one we'll discuss about So now heating effect of electric current. So that is about we'll discuss here now. Hello. V equal to W by Q. W equal to V into Q. Power equal to rate of doing work. VQ by T. So Q by T is current. Q by T is current. Okay. Then so we can take P equal to VI. So energy is given to the conductor P into T. VI into T. So we know V equal to IR. We know V equal to IR into I into T. So whatever the energy is given, that is converted in the form of heat. So the source of energy continuously gets dissipated entirely in the form of heat. Is called heating effect of electric current. So V equal to W by Q, W equal to VQ. So you can take cross multiply. V equal to W by Q. Potential difference is equal to work done. Work done to bring unit positive charge from point to another point. So W equal to VQ, P equal to W by T. So W equal to VQ. So Q by T is current. So P equal to VI. E equal to P into T. VI into T. V equal to IR. E equal to IR into IT. So whatever the energy is given to the conductor, that will be converted in the form of heat. So it's equal to I square RT. I into I square R into T, RT. So I square RT. So this is also known as Joule's law of heating. This is also known as Joule's law of heating. Okay. So heat produced in the conductor is directly proportional to current flowing through it. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay. So short circuit and electrical potential. A short circuit is there. The direct contact of live wire and neutral wire takes place. Then the direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the mains and high voltage appliances on at a time. Then it leads to the short circuit. Okay, so thank you so much for joining, attending, listening my class. Thank you so much. So if you like the video, if you like the content, if you like the explanation, do like, share and subscribe to Student the Brand. And one more thing, so there is notes, okay, for CBSE grade 10 physics, light reflection, diffraction, human and color world, electricity and magnetic effects of electric current. Okay, so the 4 chapters notes is available. You can check in the description below. So Telegram link is given and Instagram channel also, Instagram page is there. So you can do like, share and follow. So thank you so much for joining and attending and listening. So this is our Siva sir from Student the Brand signing off. Thank you.